Okay, we're here today looking at motion graphs. Specifically, we're going to look at position versus time graphs to start us off here. Hopefully, you've got to play with some of the Universe and More technologies that are online. I'm kind of looking at some of these things and just kind of fiddling with them. Maybe you got an idea of what's going on with these graphs. But if you don't, or if you want more in depth on that, that's what we're going to look at today in this little slideshow here. We'll describe what's going on. So, what we have here is up top our classic number line that we've always had. And if we take a look at this up here in the number line, what we have is an object that we'll say is initially at position 1, and then it moves in 1 second to position 3, and then in the next second, so 2 seconds later, it moves to position 4, and it moves back to position 2 in the 3rd second, and then in the 4th second, it is down here at -1, okay? So that's just how this thing is moving. We can see it moves 2 in 1 second, and then 1 in 1 second, and then 2 in the left in 1 second, and then 1, 2, 3 in another second. So we get this idea of kind of it's moving faster and slower along this. If we look at this position graph, though, we can map this position not on a number line, but on a position versus time graph. Because if we look at this number line up here, it kind of looks weird how it like cycles back. Like, what is going on in this cycle section here? Like, that's kind of weird. But what we can do instead is, instead of just listing these as time increments, if we put time on this x-axis here, so this is time, it's labeled down here, we can just plot our positions. We can say at time equals 0, our position is 1, and we have a data point right there. At time equals 1 second, so right here, our position is 3, and that's the position. At time equals 2 seconds, the position is 4. We can keep plotting these for each of our positions in time. And this is actually a really cool thing we can do here. We've gone down past a position of 0, so we're at a negative position, and that just means we've gone left of the 0 point on a number line here. So that's what we're looking at. This is just how we can plot it. We just take this number line, we tilt it to the y-axis, and our x-axis becomes time, and this is a position versus time graph. Now, since we read the position of these objects, we need to be careful about how we read the distance traveled and the displacement from this graph. Because for both of them, we think about these in terms of position for distance and displacement. We can read them from the graph here. So on the left, for our example, we have a distance traveled. On the right here, this is our displacement. It's our vector. So from 0 to 2 seconds, we're going from here, and then 2 seconds later, we're coming up almost to the peak of this graph, right? There's the bell. Figures. If we want to read the distance traveled, well, I actually don't count anything to the right. That's counting time. I want to count a distance here. So what I need to recognize is I start at 1, and then I'm going up to this 4 here, which means as I do this, I'm walking up 1, 2, 3. So our distance we've traveled is 3. Those are in meters. Now, for our displacement is a very similar idea, but there's a difference there because the displacement is a vector. Remember, for our displacement, we always care about our final position minus the initial position. That's what that delta means. So for this, all we say is, where do we end up? Well, we end up here at 4. That's our final, 4. Minus, where did we start? 1. 4 minus 1 is 3. Woo, we did it. So in that case, we were only moving to the right. Our distance and displacement was the same. Now let's look at between 3 and 4 seconds. 3 to 4 seconds, we're here to here. So we're looking at this point and this point. The point's near the end of this. And we'll do this in a different color. Let's do this in like a green. Okay. Well, for our distance, we're traveling from 2, because that's our point, and we're ending up down here at -1. So we're going 1, 2, 3. Well, we counted 3, so it's still 3. But for our displacement, it's final minus initial. We ended at a position of -1 minus the initial position of, well, +2. -1 minus 2 is -3. So while we did take 3 steps, our position changed by 3, that's a distance. For our displacement, we moved down or backwards along this line, as we came to the left here. We moved -3. Okay, so that's what's going on there. If you look at 1 to 3 seconds, things become slightly more challenging. From 1 to 3 seconds, we're looking at a variety of points here. We're looking at, oh, that's a bad color. We're looking at from 1 second to 3 second, which is this point here, and then this point here in red. So to count a distance, we need to count every step we take, and we're going both up and down. So we start at 3, but we're going up to hit 4 at the peak. That's 1 step. Then we're coming back down to the 3. That's 2 steps. And then we're going 3 to 2 for a 3rd step. So there's 1, 2, 3 steps we've taken here. That is 3 meters. Okay. When we look at our displacement, oh, there's the bell again. We ended at a position of 2, so that's our final, minus our initial position of 3. This gives us -1. Okay, so our displacement is we've really just come down 1 start to finish, but every step we took had to be counted for the distance. So going up 1, down for the 2nd step, and then down for the 3rd step there. Okay, so distances and displacements are different, but we read them both just from the graph. Okay. Now, something else we can do on this graph is we can get the velocity. We talked about this a little bit earlier in the year, but if we have any graph, the slope of a graph is just the change of the y-axis over the change of the x-axis. And remember, these are the axis we're talking about. Now, if we take a look at the axis we have on this graph, what we have is a distance and then a time, or a displacement and a time, depending on what you're looking at there. So that means the slope of this graph here is a delta x over a delta t, which we know this is just like meters per second. This is a velocity, or if we're looking at distances, it is a speed. Okay, so the slope of this graph equals the velocity, and truly it does really equal velocity, because as we're going to see, this slope could be positive or it could be negative. And to find that slope, we just take 2 points on that graph and do a rise over run. So what we have here is, even if we took these 2 points or these 2 points, notice that this is a nice linear line. It's a straight line here. It's going to have the same slope no matter what. 2 over 2 or 1 over 1, that gives us a positive 1 meters per second. And it's positive because this line is moving upward away from the x-axis. Okay, it's moving away from the x-axis. Now, what happens if we kind of get a strange looking graph here? So now we've got this curvy graph. So the velocity, or the position graph, is in blue here. How do we find velocities of this? Because if I took 2 points, if I was like, hey, what's the velocity between this point here and this point here? Like, that's kind of weird, right? It doesn't really look appropriate. You can still get a velocity from that, but that's an average velocity. And what we want is an instantaneous velocity. So what is the velocity at exactly 2 seconds? So when the time is 2, this is your position. What is the velocity right there? And the way we get this is using something known as a tangent line. A tangent line is a line that only strikes the graph at 1 point. So if I drew this tangent line here, it would look like this. And an easy way to think about tangent lines, and something that I always like to do whenever we're in class, is I'll draw a circle on the board and I'll say, draw me one line that extends forever, that touches the circle, but doesn't go through it. And what you would do is you'd say, like, okay, well, like, if here's the circle, I'll draw the line like this. You have touched the circle, but you haven't gone through it. That is the tangent line there. So if we wanted a tangent line for, like, this point right here, well, we could. It would just be just like that. So here are a few tangent lines that get drawn in here. Notice this velocity here is negative because it has a negative slope. And here, this velocity is 0 because that is a flat line there. Okay? Remember, a flat line has 0 slope. So we get a velocity of 0 at that point. Okay? Remember, these are velocities because it is signifying the direction that these objects are moving. Okay? Now, if we take a little look at this graph here, let's just kind of work through this together, get a little bit of practice in. So this is just some position time graph, and what we're going to do is we're going to look at points, or at the graph between these points. So if we go blue to blue here, we've got 5 different options of what could be occurring. Are we at rest during that spot? Or are we moving at a constant positive velocity, a constant negative velocity, or are we increasing or decreasing speed? Okay, so if we look at this first segment, which we've kind of colored in blue here, what's going on? Well, if we take a look at tangent lines here, we're going to start off kind of flat, like we're not moving. But then we increase a little bit, and then we increase a lot. So it looks like our velocity is starting from 0, and then it's going up and going up and going up. Well, that'd be like speeding up. That's like accelerating. So this first one would be D, acceleration. When we look at the second set, from this point to this point, we have a nice straight line. And when we have a straight line, we're going to have a constant velocity. The question becomes, is this a constant positive or a constant negative? Well, this is a positive slope on this line because we're pointing kind of upwards. So this would be B, a constant positive velocity. When we look at the next part, we'll do this one in green. It's going to arc over like this. Well, if we look at our tangent lines, we start steep and then we start flattening out. Well, when we flatten out, that means we're losing velocity here. We have a nice slope, so we have velocity, and then we have less velocity, and then we've got 0 velocity up top when it flattens out. We had to be decreasing our speed here, which is E. Now up top, we'll do this one in red again. We just have a flat line, okay? Technically, this velocity is constant, but it's a constant 0. That slope there of that line is 0, and because it's at 0, this is at rest, we have an A. Take a minute here for the next 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Pause this video, see if you can categorize A, B, C, D, or E, these last things we have here, and then unpause the video, and I'll go through these and we'll see what we get together, okay? This is a very important thing because we're going to have to look at a lot of these graphs throughout the year. So try this out, let's get some practice with it, and then we'll just see what kind of goes on. Okay, so pause, resume. Okay, so hopefully you tried that out. If you didn't, what are you doing? Go pause this video and then come back. So let's take a look at another one. Right here, what's going on? Boop, boop. This one's a little tricky. We start with our tangent line being flat, so we're not moving. And then it gets a little steeper. And then it gets a little steeper. So our tangent lines are getting steeper. That would mean we're speeding up. But they're also pointing down. Is that speeding up or is that slowing down? Because the velocities are negative. We have these negative sloping lines. But we are going faster. This is actually increasing our speed here. We are accelerating. It's like if you had your car in park and your foot on the brake and you weren't moving, and then you put it in reverse and then slammed on the gas. You're speeding up, but you're just moving backwards. So this graph, because the slopes are negative here, they're pointing down, we see that we have a negative slope, but we are increasing our speed because that slope is becoming more vertical. We're getting more of that slope. For the next point here, let's do this one in, I don't know, purple. We've got this straight line between these points. Well, that's a straight line, so it's a constant, and it's pointing downward, so that's a negative, okay? So this is a C, constant negative velocity. The next one here, we have steep tangent lines that then flatten out, so we must be slowing down. That's E. And then the next one is a flat line, so we get an A. And then continuing from that, we have something very similar to what we had up here. We are at rest, and then our tangent lines are getting steeper. Yes, they are pointing down, so we are still in reverse here, but we are increasing a speed, so that is D. This is a straight line pointing down, so that's a constant negative velocity. And then this is the same thing as what we had right here. We have some constant negative velocity that then begins to slow itself down, so that's a decrease in speed. We are flat, so that is at rest. And then here, we're at rest, we're speeding up, so we're increasing our speed in a positive direction. We are constant in a positive direction, and then we have this speed, and then we lose it, so we must be slowing down. Okay, so that's how we can look at some of these problems here. What's going on with this? These are position graphs. We do this there. So take a look at some of the practice problems we have with these position graphs. Try them out. The answers are at the bottom of your sheet, but cover them up, try them the first time, and then see what you do. If you're having problems with this, don't worry about it. A lot of people have problems with this the first time they do it. It takes practice to get good at it and to start thinking about things in this new way, okay? But I'm sure that you give yourself a few shots at it and you'll be able to do this as well, because it is one of those things where once you know how to read the graph, you can do it in your sleep. But for right now, that's it. Hope you enjoyed the video. Check out those practice problems, and until next time, adios.